In programming, we use variables for values that could change, or when we don't know ahead of time what the value is going to be. Constants, on the other hand, are used when the value is known and cannot possibly change. There are some examples of constants in MATLAB. These are actually functions that return constant values, but we can think of them as just constants. Pi, is built in as pi. Both I and j are built in as the square root of -1. INF is a built-in constant for infinity, and NaN stands for not a number. It's something mathematicians use. For example, if you try to divide 0 by 0, the result will be not a number. It's really useful in many times to have random numbers generated. So MATLAB has several built-in functions that generate random numbers. Although they're actually not really random, we call them pseudo-random. They're random in that you shouldn't be able to guess how they're arrived at. Random number functions, or random number generators as they're sometimes called, start with a number which is called the seed. This is either a predetermined value or it's a number that comes from the built-in clock in the computer. By default, what MATLAB does is it always uses a predetermined value, so it will always be the same. So what that means is the first time you get into MATLAB, you get a random number, you take a note of what it is, get out of MATLAB, get back into MATLAB, get a random number, you'll see it's exactly the same as before, and that's because it always starts with the same seed. If you want to change that, if you want the seed to use the built-in clock in the computer instead, then what you do is you call the RNG function, which is short for random number generator, and pass to it a string that has the word shuffle. So that will change the seed based on the current time and the current day, so that will always be a different number basically. So anytime you use RNG shuffle, you're going to create a brand new seed for the random functions. There are a couple of functions that generate random real numbers. The function rand generates what are called uniformly distributed random real numbers in the open interval from 0 to 1. Calling it with no arguments returns one random real number. If you want to generate a random real number in the open interval 0 to n, where n is some integer, you would just say rand times n. So rand will generate a real number in the range from 0 to 1, multiply that by n, and you get a random real number in the range from 0 to n. If you want normally distributed random real numbers, you use rand n as the function instead of rand. To get a random integer, you could round a random real number, but these would not be evenly distributed in the range. So instead, we can use a built-in function called randi. There are several ways of calling the function. If you call it randi and pass one argument, which is I max, it'll generate a random integer in the range from 1 to I max inclusive. You can also pass a range of values, for example, randi in parentheses, and then inside of square brackets m, n, 1 generates one random integer in the range from m to n. So again, you can specify the range of values that you want for your random integers. So notice that you have a rand function for random real numbers, you have randi for random integers, but they're called in different ways. We work with numbers a lot in MATLAB, but we also work with characters, so it's useful to know a little bit about how that works. A character is a single character in single quotes. Basically, all of the characters in the computer's character set are put into an order using a character encoding, for example, one that's called ASCII and pronounced ASCII. So if you look at a keyboard, for example, you'd see all of the characters there. Those are the possible characters in the computer's character set. So again, all of these are just put in an order. They're put in a sequence. Standard ASCII has 128 characters. The integer equivalents are 0 to 127. So all the characters are put into this sequence and they're given an equivalent integer value. You can use any of the number functions to convert a character to its integer equivalent in the encoding sequence. For example, int32 of x will tell you where x is in the encoding sequence. The function char will do the reverse. So char will convert an integer to the character equivalent. So that's for single characters. You can also have character strings, and those are sequence of characters, again enclosed inside of single quotes. So in MATLAB you use single quotes for single characters and also for character strings. We can create relational expressions in MATLAB using relational operators. The relational operators in MATLAB are the greater than symbol for greater than, less than, greater than or equals is the greater than symbol followed by the equal sign, less than or equals is the less than symbol followed by the equal sign. Equality is two equal signs in a row. Remember that the assignment operator is a single equal sign, so we need something else to mean equality, and it's two equal signs in a row. And then inequality or not equals is the little tilde symbol, looks like a squiggle, followed by the equal sign. The resulting type for any of these expressions is logical. If you have an expression that is conceptually true, it actually has the logical value 1, and if you have an expression that is conceptually false, it actually has the logical value 0. So for example, if I said 3 less than 5, that is conceptually true. 3 is less than 5, so that expression actually has the logical value 1 as a result. We also have logical operators that relate two of these relational expressions. We have the OR operator, which is two vertical lines in a row. We have the AND operator, which is two ampersand or AND symbols in a row. And the NOT operator is, again, the tilde. There's also an exclusive OR function. You pass to it two of these relational expressions, and it will return logical true if one and only one of the arguments is true. Here's a truth table that shows how some of these logical operators work. If you have x, which is logical, and y, which is logical, and for example, x is true and y is also true, then not x would give you the opposite of x, so not true would give you false. True or true would give me true. True and true would give me true. Exclusive or true, comma true would give me false. So again, if x and y are both true, then that would be the result. So if x is true and y is false, you see the results from these expressions. And then if they're both false, you also see the results from these expressions in the truth table. And note that these logical operators are commutative. So here's now an expanded precedence table that now includes these relational and logical operators. So the highest level of precedence is parentheses, then exponentiation or power is next. The unary operators, meaning operators that operate on only a single thing, including negation and not, those are next. Then all of the multiplication and division operators, then addition and subtraction, then all of the relational operators, and, or, and the lowest level of precedence is the assignment operator.